My research is in title of filling the gap between design and construction phase when using BIM in MEP sector. So the table of content for this presentation is first introduction, then seeing the case study and challenges and gaps that I found, and then document analysis. And after chapter 4, we will see the possible way of filling the gaps in 2D BIM process, software usage, 4D and 5D modeling, data type, connector platform, ordering status, and finally conclusion. So let's go to the chapter 1, introduction. This research started with this main question: what model need to be prepared for the construction phase and with which framework? How to link the model to the construction phase and with which connectors? If the model and the connectors are prepared, how to use the model and for what? So I want to just connect this question to these BIM fields that are, all these questions are related to policy, process, and technology. So let's go to the case study. My case study was in the Netherlands, and the requirement for choosing the project was a project that the MEP part of it has the main role of the building, and the installation process is complex. Model is created with BIM mindset, and also the documentation is available for research, and also visiting the project is feasible for me, and both design and installation phase has done by the same company to can do my research on. So let's see the case study. To have an overview of the project is a laboratory of viruses, and mostly I worked on the floor 2 of this building, which contains more than 8,000 components, and contains the most most MEP parts of the building, such as AHU, freezers, chillers, gas cylinders, various ducts and filters. So, and you can see the location of these main components in the map. So what was the challenges and gaps? I found 6 challenges and gaps in this process for connecting the design phase of MEP system to construction phase. The first part is a gap in 3D modeling, which is having the consistent data in the 3D model. The next part is 4D modeling, which the schedule is not connected to the model, but in the because of the complexity of the installation of MEP systems, sometimes we need to have day-to-day planning. And the next part is having the is in 5D modeling, which the ordering status of the cost report is not actually connected to the model, and after that for all the process from tendering phase to the installation, the order of information is not the same, so it makes the process more challenging. Another part is in CD documentation. Some documents, as you know, the process from the tendering to installation and then maintenance and life cycle of the building, we will prepare a lot of documents, and some documents are lost during the process, and also having the access to the latest and approved version of the documents is actually challenging. And also because of the connectivity between data, it's another challenge that I found that we will see in the next chapter, the connectivity between data. And the next part is collaboration. The status of the project is not clear and shared for all the participants, and communication and collaboration is mainly right now via email and telephone, and decision-making is hard. Because different teams work in different locations, so actually it needs to have a shared platform to connect these different teams together. And also validation and qualification on MEP system right now is mostly paper-based documentation. And also in the ordering status that I worked on it, right now the document of status of the components are in Navision. It's one software, and then when we want to check the model and check which components are available or not, we need to mostly be connected with the work planner. So Just I want to go to the documentation analysis, and I want to just show you some 6 document and model that is the main document for MEP system, that I want to just go through the direct connection between this document. And as you can see here in this process, if we change a number in one document, it will affect other documents. So it's need to have the shared platform to notify someone that we change some part of the documents, and it's as an input for output of one document can be as an input for another step. So it's really seems important. So because the documentation is mostly a manual process, it makes a lot of mistakes in documentation, and lots of documents are duplicated or copied, and finding the final version is hard. So let's go to the solution and way of filling this gap. The first part is a 2B BIM process that will answer this question, that with which frame of work. And I prepared a BIM process from tendering phase to archiving the project after installation, and I grouped the similar activity together to have the maybe a simpler MEP process. So I want to just say first, it's really important because as I said, the output of a group can be as a input for the next step. So having the overview of all the process is really crucial for a different group that work together. So the next part of my dissertation that I did was software usage, that how to link the model to the construction phase and with which connectors. I used 28 criteria for selecting the best software for my project that I can use. I don't want to go through each of them, but you can see the criteria. And I research on deeply in which software can do what and which one is better for my research. And finally, I used Dalux and Navisworks. Navisworks as a platform for 4D and 5D modeling and embedding the ordering status of the components, and Dalux as a platform dynamic for a platform for dynamic data, and also checking the model, adding the comments, workflow. Actually adding the workflow to the components. And there were some other criteria that makes important for me to select a good software for my project, something like the support and availability of the software for me, availability of forums and videos for anticipated issues during the process. So let's go to the 4D and 5D modeling. What model needs to be prepared for the construction phase? Just I want to say first, the process of installation of MEP is really challenging because the process is really complex and some components may change during the process of design. Planning for the installation depends on the available components, will change the process, and also limitation in available space in the target room is another challenging. Working space and transportation is another challenging. And also the open space that the building can provide for us to enter the component that we want to install makes the process of installation more challenging. So it seems it's really important to connect the schedule to the BIM model. So before for the modeling, it needs to think about which part of the model we want to install first, and how detailed we want to make, or how detailed we want to make our 4D model. Depends on the project, depends on the place and available space that we have. And for this project, I use system that you can see each system with different color, and I define the sets in Navisworks. And after preparation of MS project and connecting MS project to the Navisworks, I had my 4D simulation. The next part is 5D modeling. It's really crucial for the project manager to have more control over the project and budget, to have an overview of total cost of each room or each floor or each phase of the project, which right now it's not, and it's a total cost of each part, and it's not really easy to control the budget. So after defining the quantification in Naviswork and adding the total cost, after 4D modeling, actually, we will have the 5D modeling. And as you can see here, for installation, the MEP system, you can see here in each day, each month, and each year, we will install which part of the MEP system. And you can see the defined task ID that I defined in MS project before, and also the total cost of the target components that we want to track. So the next part is data type. As I researched, there were two types of the data in the MEP system. One of them is the dynamic data, and another is static data. The dynamic data is the type of data that regularly changes, and usage is for the progress project, and various teams will work on the same time on one project. So it's actually the dynamic data that we are working on. And the static data is that are consistent, and the usage is for archiving the project that is finished, or we want to use it for the future usage, or archiving the templates, components, or group of the components that we want to use in the next project. So each of these type of data needs a different platform. Dynamic data, for the dynamic data here, I use Dalux as a shared platform that will connect the data to the model, and also connected the data to the workflow, and it's easy to add review and photo to it, and in a shared platform. But for the static data, we started to develop a local platform, share and local platform, and give access to the target group that needs to have access. So the next part is a connector platform. For the connector platform, I want to just first say we have a two way of working. The old way of working is paper-based documentation. We have issue with communication, and because sometimes we need essential information, the installer need to be connected with the engineering in the office, and it's regularly via email and phone call, and the notation is handwriting notation, and archiving the project is not convenient, and the workflow is not connected to the model, and also tracking the progress of the project is not that much easy. But in the digital way of working, the model is connected to the workflow, and communication and archiving the notation is more convenient, and attaching the photo and comments to the model is feasible, and meeting can be done through the software, and also accessing to the latest version of the documents, and checking the ordering status is more convenient for installer, and also viewing the detail of the components in the platform. So let's go. I need to check. Okay. Dalux has 4 different parts: dashboard, location, field, and box brew. The dashboard is a part that is just shows the upcoming deadline, and also you can check the tasks there. Location is mostly a part that we can check the 3D model detail and adding the filters to it. And as you can see, as much as we add the detail to the model that needs, we can check it there in the location, and it's more convenient for installer to install the components that they want, or check the detail of that components. The field part of the Dalux is mostly the main part that can connect the MEP model to installation phase, that we can assign the forms, tasks, and also approval version of the document, and also the 360 photo of Dalux can provide us a reality model of the current installation that is really easy to check the installation with the MEP model. And the box brew is mostly the dynamic CD that adding all type of the data with or ordering of documentation that once it's possible. So checking the detail of the MEP system is easy with this platform, and adding the comments and photo to it, and also it needs to have to check the model not in just 2D, in 3D it's possible for installer too. So the next part is ordering status, that I export the data from Excel from Navision into Excel file, and then with adding the Excel file to Navisworks, we can see the data in Dolux in real time. So the good part of this way of working is we push the temporary data to our viewer, not to our model, model, and then because it's temporary and will change during the process, it's not actually needs to embed in our base model. So and also another possibility is to check to adding the type of data that we want to add. Not all the data is not available in Dolux that as a model viewer that I use for this case study. So after that, with exporting the data to Dolux day by day, it's available for installer to check by phone the status of the order, and it's not even necessary to check with the engineering department that which components are available right now or which are not. And also with defining the filter for them, it's not needs to have the complex training system for them. They can just switch between ordered or not ordered components. And just I want to go to the conclusion. That is all I said in my presentation. The identified gap was in design and detailed design phase, in documentation, in collaboration and communication, in installation, in ordering system, in workflow and process. And I want to say thank you to my supervisor from company and university. Thanks for your time.